Good morning, Tehmina Khan is here in TKMaths is fun. Today's video, which is on lesson Forces and Newton's Law of Motion. It is a series of complete lessons of M1 A-level mathematics, and this video will be video 4.2, which will cover Newton's third law and little bit about connected particles. For the rest of the video, you can find the link in the description below. So let's start Newton's third law. Newton's third law states that for every action, there is an equal and opposite reaction. This means that in every interaction, there is a pair of forces that have the same magnitude but acting in the opposite direction. Now, what does this mean? Let's understand this with the help of the example. And the diagram is also here. You can see here. When a boy uses a rope to pull a box, this is the box and this is a boy. And this is the rope with which he is pulling it. The force with which the box pulls on the boy. Now the box is pulling the boy, right? So these forces is opposite to the force with which the boy pulls the box. So these two forces are equal and opposite. So magnitude wise they are equal, but in the opposite direction, and definitely this force is the tension in the rope. So here I have taken few more images to make you understand. For example, the book is on the table. So the weight of the book is acting downward, but the table will push the book upward. Because it is stationary, these two forces are equal and opposite in direction. Sometimes, when the book is very heavy or any object which is very heavy and you put it on the table, it breaks. It means it is not supporting it. In that case, it is not equal and opposite. That is a different situation. Now here the boy or the man is pulling the wall, and wall is also reacting in the opposite direction. This is also Newton's third law of motion. Here in this balloon, reaction and action. Air rushes down, balloon goes up because of the same thrust. Okay. Now force diagram. It is very important that you are able to apply the force properly. All the direction of the force on the diagram, because it is a requirement of the exam question as well as to able to solve it correctly, you should be able to identify all the forces on it. So suppose this is a boy sitting on the chair. First of all, you have to draw forces acting on a person. What it will be? Now if you see the B, just a minute. If you see this B, what is B telling you? Force of chair back on a person. Otherwise, person will fall back. If you are leaning against and back will not push you, then you will fall back. Force of a chair seat on person, you can see here. Otherwise, chair will break and you will go down. So it is also forcing you up. And W1 is representing weight of the person. He is on the chair. So when we will see the forces acting on the chair, we will talk about the weight of the chair. But right now we are talking about forces acting on person. So we are talking about the weight of the person here. And his both the feet are on the floor. So reaction of floor on person. Now see forces acting on chair. So definitely it is the boy who is pushing it backward on the back seat. So that's why they are equal and opposite in direction. Similarly, force of person on seat chair, this one. Can you see here? It is equal and opposite. Now these two, which is R1 and R2 representing, R2 and R3, which are the weight of the chair on the floor. And of course, floor is holding it. So it is applying force upward, which is not shown in this diagram because here we were talking about with respect to person only, right? And this is definitely the weight of the chair. And in this case, it was the weight of the boy. So I hope you understand these directions. We will see more questions. Now I'm coming to connected particle. Now here something is very important, because all the questions which are of different type of connected particles, I will show you one by one. Few examples of few images I have taken here, so you can understand what type of questions are asked in connected particle. They need more information about friction, about resolving forces, which will be explained in the upcoming videos. So here I will take only one example, which is only solving around Newton's second law or third law, right? But I'm telling you here by showing you the images that these are the type of connected particle question oftenly asked in the exam. Situations different, so we need to understand more information here. What is maximum friction, what is a coefficient of friction, what is resolving forces, then we will be able to solve all these types. At this point, at the end of the next video, I have explained past paper question only considering Newton's second law, right? So let's see one example here. In a connected system, you can apply Newton's second law to the entire system or to the individual of the system. Now, what does this mean? Let's see here, because this is something very important and helpful to solve questions and to get the desired result. Okay, so the diagram is given here. A car is using a tow bar. You can see here with the red thing, it is written here. A car is using a tow bar to pull a trailer along a straight level road. There are resisting forces R acting on the car and S acting on the trailer. You can see here, this is the resultant resisting force on the car, and this is the resisting force on the trailer. The driving force of the car is D here, and its brake force is B, right? Now this is not mentioned in the diagram. Brake force is B. So now if you are writing the let me write here brake force. Brake force is if you will apply brake only. At the moment, suppose there is no brake force, right? Car is going on the road, it is towing a trawler, and of course while it is moving, it is experiencing these resistance forces. So at the moment, forget about braking force. Now in this case, if you have to write Newton's second law of motion with the help of the individual or with the help of system, how will you write it? Let's see. Newton's second law is F is equals to ma. F represents the resultant force. So if I'm talking about the whole system, these two forces will cancel out. Why? Because they are equal and opposite, so they will cancel out their effect. So it will become forward force is driving force minus the resistive force of the car minus the what it is called resistive force of the trailer. So this is your resultant force is equals to m. Now mass will be the mass of the trawler and the mass of the car. So this is how you will write down the equation for the system. Let's write it separately for car and for the trailer. So for car, what it will be? So now you will consider only this part, okay? Only this part. So according to Newton's second law of motion, the resultant force will be D minus. Now why I'm doing D minus? Because I am considering here that car is moving in this direction. So that's why I'm taking that this force is larger compared to the resisting forces, right? D minus R minus T, minus T is equals to ma. So this will be my equation of motion for car. Now let me write it down for trailer. Can you try out for trailer what it will be? So for trailer, you will only consider this part. So what is the forward force? T. T minus S is equals to capital M NA. So this is how you will get two equations for system or for individually for car and for trailer. If braking force apply here, then we will do minus B also. But right now I'm considering it is not there. So let's see this example, and this is the last example for this video. Whenever you get a question in M1, always sketch roughly, write all the forces in it, then the chances are that you will not make mistake. Some people are very sharp, they can do it mentally. Choice is yours, but it's better that you sketch it roughly. So I have done it here. A car towing a trailer along horizontal straight road. The car has mass 1500 kg. I've mentioned it here. And the trailer has mass 500 kg. The resistance to motion by car is 80 Newton, by trailer 20 Newton, and the green one is your tow bar between them. You have to find the tension in the tow bar, and the driving force is 360. So let's solve the same question with the help of the considering whole system and considering individually, right? So now first suppose individually, okay? So with respect to car and with respect to trailer, you can put the video on pause if you want to try out yourself first and then play it. Meanwhile, I'm solving it here. So if I look at the car, it will be driving force. I can represent it by D minus, tow bar, the tension in the tow bar will be cancelled out because they are equal and opposite. So minus 20 and minus 80. These are the resistance forces. Just Newton's second law of motion is F is equals to ma. Masses will add up. So 500 plus 1500. Right. So it will become what? D. Oh, driving force is given to you in the question. It is what? 360. It's given here, right? So 360 minus 100 is equals to 2. Oh, I'm sorry. I'm doing it for the system, whereas I said do it for car. Okay. So just so let's take it for the system because I've already done it more than half. So let's write here system first. Okay, so I'm doing it for the whole system. So that's why I'm not considering T in between. So it will become 2000 A, which is 260 equals to 2000 A. So A is equals to 260 divided by 2000, which is equals to 0.13. Please pick up the calculator and check it. So it will be meter per second square. Now if I want to find the tension, like it is saying find the tension in the tow bar, so the whole system in one go will not give me tension here. I have to separately do it to get tension, definitely. So after that, for example, if I write the equation of the trailer or the car, your choice. So trailer equation if I write, okay, I'm talking about this part. So it will be what? T minus, let me change the color, T minus 20 trailer. T minus 20 Newton is equals to 500 A, because 500 is the mass of the trailer. So T is equals to 500, A is 0.13 plus 20. So what it is? Let me check. You can also check in the calculator. I think it is coming 500 into 0.13 plus 20 is 85. So it is 85 newtons. So if you are using the whole system, you can get the acceleration, but to get the tension, you have to do this. Whereas if I do both individual, I do not do it by system. So trailer equation will be my first equation. In that case, I will not have A in first go, right? So my second equation will be with respect to car. Okay, let's write it here so that you can understand how you can solve it. So for the car point of view, it will be driving force minus tension minus resistant force is equals to mass of the car. Driving force is 360 minus T minus 80 is equals to 1500 A, which is 260 minus T is equals to 1500 A. This will become your second equation, right? And this will be your first equation. So if you are solving it individually, then you will solve these two equations simultaneously and you will get A and T. So I hope you understood. This is how we will solve the question for the connected particle. So thank you very much for watching the video. In the next video, we will solve more connected particle questions and past paper question as well. So take care. Allah Hafiz. Don't forget to share it with your friends.